Hi. This morning, I'm going to present my science project on the evolution of energy used for transport. A variety of energy sources can be used for transport: electricity, gaseous fuels, and of course the main source, liquid fuels. Has it always been the same liquid fuel? No. So let's go back in history. Liquid fuels for transport appeared more than 150 years ago and were petroleum-based for a very long time. About 40 years ago, new feedstocks began to be used, biofuels, first blended in small quantities into the original product. The inclusion of biofuels in transport resulted from the global agreements to address climate change by collectively reducing CO2 emissions. During those 40 years, continued efforts and investments in research and development for low-carbon technology enabled transitioning transport to the low-carbon sector we have today. The challenge at the time was quite simple. There was an emerging technology for passenger cars, electric battery vehicles, but no alternative for planes, ships, and trucks. In fact, the superior energy density of liquid fuels was such that it was almost impossible to find an alternative that could deliver the same performance for these transportation means. A lot of research was done to find new technologies that could provide low-carbon solutions, some quite surprising. Engineers and researchers realized that there was not one technology that could solve the equation. In fact, a variety of options were required to meet the objective of addressing climate change. Liquid fuels with lower carbon emissions over their life cycle appear to be one of those technologies. These low-carbon liquid fuels are based on a net zero carbon cycle where carbon is captured and released again after its use, making it thus net zero emission. Many technologies turned out to be really disruptive and contributed to the development of our low-carbon liquid fuels. Here are some examples. One of the first technologies deployed around 2014 is the technology for biorefineries. Such refineries convert organic feedstock, such as biomass, feedstock, and residues, and waste oils to produce the high-quality liquid fuels fully derived from renewable sources thanks to the use of green hydrogen. Such refineries are very flexible and can use almost any type of feedstock. The second technology, known as plastic to fuel and feedstock, enables converting plastic waste into synthetic crude, which will then serve to make fuels for transport or feedstock for other industries. A few years later, a low-carbon technology enabling the production of green hydrogen started to be deployed. The technology is based on the electrolysis of water to generate green hydrogen by using renewable electricity. The electrolyzer has the potential to provide large quantities of renewable hydrogen for targeted large-scale applications, either in industry or transport. The last example I will showcase is known as power to liquid. This technology uses renewable power to contribute to the production of liquid fuels by producing green hydrogen, which then reacts with CO2 captured from air or from other waste products to produce a mixture of hydrocarbon chains. These fuels are also known as e-fuels. The liquid fuels we use today are the result of all these low-carbon technologies, which enabled these tremendous emission reductions, whilst ensuring the efficiency and the effectiveness of each of the transport modes.